So we continue working with the means and analyzing means through pivot tables. The next test that we're going to learn is a paired sample t-test. So if you think about it a little bit, these t-tests have a very intuitive name. Each of them have a very intuitive name. In the previous video, we learned how to perform a one sample t-test, and we had one sample and we compared it to an arbitrary number. Now we will be doing a paired sample t-test, so we will be comparing pairs of numbers. To get to it, let's create a pivot table. So we insert a pivot table and let's drag it so that we have everything ordered nicely and we're not too lost. And rename it into a paired t-test. What we could compare, for example, is two pairs, two countries. So let's drag a year here and our values in the value column, and let's make sure that's average. And let's throw in parties into columns. Now we have all the average for all the countries. Let's use the filter and compare, this time, Austria to Hungary. Let's deselect this, select Austria and Hungary, wherever it is. There it is. So now the way we're looking at this is we have a mean value for Austria and mean value for Hungary. And it seems mathematically is that Austria has a higher number than Hungary, but we're not talking about mathematics, we're talking about statistics, so we need to know whether one value is significantly different from another. And in this way, we use year as a unit of response, so we treat each year as a respondent. In your data set that you will be analyzing at home, you will have each participant, each respondent in each line, but actually everything which makes sense can be a unit of measure. Now we would like to compare whether in year 1990 to year 2018 there was an average difference between GHG values of Austria and Hungary. To do that, we are running a paired sample t-test so that we have it easy with extending. Let's kill all the grand totals. We will have all the means in the output anyway. So let's go to design and off the grand totals. There we are, gone. Now we go to our data tool and we select a paired sample t-test paired and we click OK. Delete everything that we have here and type it again. So we're comparing Austria, Shift Control and arrow down, and we have all the Austria values, to Hungary. The same thing, step on Hungary, Shift Control, arrow down, Hungary. Let's not forget to tell Excel that we have labels also included in this range and click OK. We have a new sheet. Let's drag it here and let's rename it right away. Austria-Hungary. Let's adjust the size of the cell so that we see everything nicely, and also these values. Select them and format them, let's say like this. Now it's easy to read. We have 72,500 versus 67, almost 0.8,000. Are they different from each other? To find out this, we need to look at this value here. P-value is the one we're looking at. And it seems to be insignificant. So 0.08 is bigger than 0.05, and this is our cutoff point. So we can say that actually 72,500 mean is not different from the mean of Hungary, 67,800. However, this p-value is rather close to 0.5. And let's not forget what p-value actually means. It means that when we say that something is going on, in the context of paired sample t-test, we can say Austria has a significantly higher GHG than Hungary. There is a chance that we're wrong, and this chance, if we make this statement, is 8%. Generally, 5% is acceptable. But if the p-value is close to 5, but it's still above 5, what we can say is that it is marginally significantly different. So marginally means that we're close but not exactly below 0.5. So if you are under 10%, under 0.1, you can say marginally significant. And what also something that makes sense to look at is the number of observations. We don't have very many observations, only 29 years. And I told you, we treat them as observations. Each year is each observation, just like each person can be each observations. You can treat the data differently. And here the sample is rather small, only 29 observations. And this might be the reason why this number does not reach significance. Let's have a look at the paired sample t-test in under another angle. For example, instead of treating years as units of response, we could treat countries as units of response. So let's throw everything out and put party here in the rows. Let's rearrange the filter. So we still would like to kick something out, and especially this European Union things, because these are basically duplicates. We will have these countries separately somewhere in the sample anyways. So we have our list of countries. And now let's compare years. So we have all the years and we can select a pair we like. In this course, we already talked about and looked at the values of 2010 and 2000. So let's compare that. Let's use a filter and select only 2000 and 2010. Now we have these two values and we're comparing those values. So now our unit of observation, our hypothetical respondent is a country, and we're looking at the two response times in 2010 and in 2000. So let's see if the differences are significant. Again, paired sample t-test. Let's delete everything because the list is longer now. See, we go up to cell 47 instead of 33 now. Make sure the labels are selected and click OK. Drag the new output in order and rename it as 2000, 2010. Let's order everything right away so that it's easier to read. Numbers 1 and in US. So now we're comparing the emissions in 2000, which were 380,000, to 2000, to the emissions in 2010, which was 366. And these ones are already below 0.05, so they are significantly different. And now look, our observations is 43. Why is that? Because we're looking at 43 countries now. So if you select this and look at the count here, these are our 43 respondents, and we treat countries as our respondents. And now there is a significant difference, which is good news because it looks like on average in the world the GHG gases are dropping, or at least in the countries that are considered in the report that we're looking at. This is also something to keep in mind. We don't have all the countries here. But it looks like among the countries that we're looking at, there is a downward trend. So there is a significant decrease in GHG gases if we look at the values from 2000 and compare them to the values in 2010. In your data, you will be having respondents here as the list, and you will be comparing some of their answers. It might be the case that in the marketing practice, you will be looking, for example, at the panel data, and you will have some surveys or some purchase information from the same respondents that are measured at different times. Let's say purchases last month to purchases this month. And you as a marketer would like to know whether I increased or decreased my purchases, or the number stays the same. It's important then to remember that we can only compare things that are comparable, which is kind of logical, but sometimes it can be tempting to compare apples to oranges. For example, when I was shopping for a data set for this session, I also found another one on the greenhouse gases. And here you can see that we have different gases in separate columns. It might be tempting to compare the emissions of CO2 to those of methane, for example. But we know from the video that actually the effects of these gases are not identical, that CO2 is not, the same amount of CO2 will not have the same effect as the same amount of methane. For example, if we take N2O, we will have to multiply it by 200 so that it has the same effect as CO2. So when GHG index is calculated, these things are considered. Why am I talking about this? Of course, most of you, if not all of you, in your work will not be comparing greenhouse gases to each other. Therefore, this situation probably will not happen. Other situations might. It might be that you have a survey, you conducted a survey last year, and there you had respondents answer questions, and those questions were on a 7-point scale. This year you conducted the survey and you had respondents answer the very same questions but on a 5-point scale. 7-point scale and 5-point scale cannot be compared just the same as you cannot compare CO2 and methane without making an adjustment. In general, adjustments are possible. There are statistical tricks to do that. The best practice, however, if you have a longitudinal study, is to measure them on the same scale. If last year your question was on a 7-point scale, use a 7-point scale of this question as well, and then you can compare. Otherwise, you will have to go deeper into the scary statistics. So this is the overview of a paired sample t-test. So again, we're comparing pairs of informations from respondents. And now it's your time to play around and try some of that yourself.